Dear students, welcome to EPG Pathshala. This module is continuation of the previous module, that is Introduction to Probability Theory. In that module we discuss sample spaces, what are sample spaces, what are random experiments, different types of events, different approaches of probabilities like statistical approach, mathematical approach, and at the end of that module we discuss what is permutation and combination. In this module we discuss additive and multiplicative properties of probability, and we will also discuss properties of these things here, as well as we also discuss conditional probability in this module, as well as addition and multiplicative rule in this module. Each thing is explained in a very easy manner so that you can understand the concept very easily. Hope you can understand it. Let's get started. Basic key concept of probability were introduced in the above said module. In that module, our main concern is to give brief understanding of some basic and most important rules for probability theory. We will discuss these concepts with examples for better understanding. Addition and multiplication rules are considered as an important features of probability. Construction of formula and examples are discussed to understand addition and multiplication probability theorem in detail. Introduction. Let us suppose if there is only one task of tossing a coin 2 times and find the probability of getting head on both times. This type of probabilities problem is solved by addition rule of probability. Suppose tossing a coin 2 times one after another. If one get heads on the first toss and also on the second toss, these two outcomes are independent and outcomes of 2 tosses is not affecting the outcome of second toss. This type of probability problem is solved by the multiplication rule of the probability. Here some basic feature of an experiment will help one to understand mathematical behavior of the probability problem. These features will be helpful to understand statistical addition and multiplication probability theorem. Terminology. These are few terminology that one must be aware of before going forward in this topic. So U represents a union symbol where E union F is equal to A. The definition is A belongs to S, where also A belongs to either E or A belongs to capital F. So E is equal to A belongs to E, it means A does not belongs to E. E is equal to A and belongs to E means A belongs to E. E intersection F is equal to A belongs to S, where S represents sample space. A belongs to E and A belongs to capital F. E subset of F for every A belongs to E and A belongs to F, where E union F denotes E union F means at least one event happens. E bar denotes E complement means outcome does not belongs to E. E subset E intersection F says E means both events happen. E subset F, that means outcome of event belongs to outcome of F. Let us discuss in detail explanation of the addition and multiplication probability theorem. Let's start with addition probability theorem. A statistical property of probability theorem is used to explain happening of one or more events at one task. Suppose a random experiment selecting a card from a deck of cards, an event is selected a card Jack and Queen. Since it is impossible to draw both Jack and Queen in same draws, outcome will be either Jack or Queen. This type of probability problem is solved by using additive rule. The additive rule is used to find compound probability of one or more event with the either or statement format of the problem. In other words, the addition theorem solves the probability of happening at least one of the given events. Union concept is used to find probability of happening at least one event. Union is key concept of mathematical probability theory and set theory. This union representation looks like alphabet capital U. Since two events cannot occur simultaneously in one task and cannot have common outcomes, it is known as mutually exclusive event. If events have common outcomes, event will not be mutually exclusive event. It may be say as non-mutually exclusive events. Now the mathematical formulation. Mathematical formulation of addition probability theorem is slightly different from mutually exclusive event than non-mutually exclusive event. There is only one difference, that is addition formula for mutually exclusive does not have intersection term, but addition formula for non-mutually exclusive has intersection term. Addition probability formulation for non-mutually exclusive is the generalization of the additional probability formulation for mutually exclusive formula. Additional probability formulation for non-mutually exclusive event. Venn diagram is a graphical representation for set theory. Sample space is set of possible outcomes and event is a subset of sample space. So event is also a set of Venn diagrams that is being used here to show graphical representation of the given event. So starting with the graphic representation of Venn diagram for non-mutually exclusive under addition probability formulation. Suppose E and F are two events of a random experiment. From the figure 1 of Venn diagram, event E is shown as a blue in a blue circle, and event F is shown in a yellow circle, in purple circle. Event E and F have same common area and have common outcomes. So event E and F are non-mutually exclusive event. Additional probability formulation for non-mutually exclusive events E and F is given by the formula that here the probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F. The formulation can be read as probability of happening either event or F is equal to probability of happening event E plus probability of happening event F minus probability of happening event E and F. Suppose there are three non-mutually exclusive events E, F and G, and from the Venn diagram we can see that there is some area where these events overlap each other. So additional probability formulation for non-mutually exclusive event E, F and or G are given here as probability of E union F union G is equal to probability of E plus probability of F plus probability of G minus probability of E intersection F minus probability of F intersection G minus probability of E intersection G plus probability of E intersection F intersection G. Similarly, addition probability formulation can be extended for n events. Now, let us discuss this concept through a question, or suppose in a class there are 3 students, 7 are boys and 6 are girls. One on unit test 4 boys and 5 girls receive A grade. If a student chooses at random in the class, what is the probability of choosing a girl or A grade student? The answer here is, suppose A is an event of choosing girl and F is an event of choosing A grade student. Hence, we are interested in to find out the probability of E or F. Even E and F have 5 common outcomes, that is 5 girls made A grade. Hence, E and F are non-mutually exclusive events. We have to find probability of non-mutually exclusive events by using addition probability formula. The formula here is probability of E is equal to 6 by 13 and probability of F is 9 by 13 and probability of E intersection F is 5 by 13. Additional probability formula for two non-mutually exclusive is given as probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F, where probability of E represents the number of possible number of favorable outcome divided by number of possible outcomes for event E. Similarly, for probability of F is derived by using this same formula. So after putting the values of these events in this formula, we will get the answer 0.7692. So probability of choosing a girl or A grade student is 76.92%. That means we are 76% sure that when we select a person, a girl or A grade student is chosen. If the let us consider another example. If the probability of solving a quiz by Ruby and Kiran are 3 by 4 and 2 by 3 respectively, what is the probability of solving the quiz? Let E and F are the events of solving a quiz by Ruby and Kiran respectively. The probability of these events are given here as 3 by 4 and 2 by 3 respectively. As we are interested in solving the quiz, hence there are the following possibilities. First possibility is that either Kiran solve the quiz or Ruby solve the quiz. It means that quiz will be solved by at least one of them. Second possibility is that both solve the quiz, as Kiran and Ruby can solve the quiz independently. So we can consider event E and F are independent event. Therefore, probability of E intersection F is equal to probability of E into probability of F. As the probability of solving the quiz by at least one of two events is represented as union of two events, so the probability of probability of the favorable event by using additional probability formula is given here as probability of E union F, which is coming out to be 0.9166. Hence the probability of solving the quiz is 0.9166. Now coming to the definition of mutually exclusive addition formula. Suppose E and F are two events of random experiment respectively. From the Venn diagram, event E is shown as blue circle and F is shown as purple circle. Event E and F do not have common area and same outcomes. So event E and F are mutually exclusive events. Addition probability formula for mutually exclusive events E and F is given here as probability of E union F is equal to probability of E plus probability of F. This formulation can be read as probability of happening either event E is equal to probability of happening event E plus probability of happening event F. If there are three mutually exclusive events, and the formula for this case is addition probability formula is probability of E union F probability of E union F union G is equal to probability of E plus probability of F plus probability of G. Similarly, additional probability formulation can be extended to any events or outcomes. Now, let us consider another case. Suppose in a group of 50 members, there are 15 junior students, 20 senior students and 15 instructors. What is the probability that a person randomly picked from this group is either junior or senior student? Let E and F be events of selecting junior and senior student respectively from a group of 50 members, as event E and F do not have any common outcomes. Student can either be junior and senior, so E and F are mutually exclusive events. Additional probability formulation is used to find probability of picking a member from a group of 50 members that can be either junior or senior student. So probability of event E and F are given here as probability of E is equal to 15 by 50, probability of F is equal to 20 by 50. Additional probability formulation for two mutually exclusive events is given as probability of E union F, which is equal to probability of E plus probability of F, and after putting the value we will get the answer as 0.7. So it means probability of selecting a junior or senior student randomly from this group is 70%. Suppose a card selected from a standard deck of card, what is the probability of selecting either ace or queen card from a deck of card? Let us consider two events E and F. E represents selected card is ace and F represents selected card is queen. As event E and F do not have common outcomes, so E and F are mutually exclusive event. Additional probability formulation is used to find the probability of selecting card either ace and queen. So probability of event E and F are given by probability of E is equal to 4 divided by 52, because we have 4 card of ace, and so the probability of E is equal to 1 by 13, and similarly we have 4 cards of queen in a pack of card, so the probability of F is coming out to be 1 by 13. So additional probability formulation for two mutually exclusive events is given as probability of E union F, which is coming out to be 2 by 13. Hence the probability of selecting an ace and a queen from a deck of card is 2 by 13. Now coming to the definition of conditional probability. So when one event has a relationship with other respective events, suppose event E is the event that is related with raining, that is 0.7% chance of raining. Conditional probability is used to find out probability of these types of events. Conditional probability measures the probability of an event given that one event occur. Suppose E and F are two dependent events of random experiment, and conditional probability formulation for dependent event is given as by the formula probability of E given F is equal to probability of E intersection F divided by probability of F. So this formulation can be read as probability of event E given probability of F, which is equal to probability of event E and F divided by probability of F. Suppose E and F are two independent events on random experiment. Conditional probability formulation for independent event is given as probability of E given F, which is equal to probability of E into probability of F divided by probability of. So probability of F got cancelled, so we left with probability of E. This formulation can be read as probability of event E given F is equal to probability of E. That means occurrence of E event does not depend upon whether F event occur or not. Here a sports person group buys 60 sports car, 30 bought alarm system, 20 bought bucket seats and 10 bought an alarm system and a bucket seat. If a car buyer chooses at random bucket seat car, what is the probability they also have a alarm system? Suppose F is an event denoting car with bucket seat, E is an event denoting car with alarm seat, and E and F is event denoting car with both bucket seat and alarm system. We have to find out the probability of a car having alarm system given that it has bucket seat. This probability can be found by using conditional probability formulation for dependent event. So probabilities are given here as probability of E is coming out to be 30 by 60. So the answer will be 1 by 2. So probability of F is 20 by 60 and the probability of E intersection F is 10 by 60. So conditional probability formulation for dependent event is given here as by using the formula of addition formulation, and after putting the value we will get probability of E given F is coming out to 0.5. So it means probability of a car having alarm system given that it has a bucket seat is 0.5. So now here we will start a new topic, that is multiplication rule. A statistical probability or probability theory is used to find out the probability of happening event in more than one task. Suppose two dice are rolling followed by one after another, and we are interested to find out the probability of rolling 3 on one dice and rolling odd number in second dice. Here two tasks are happening. One is rolling dice first time and second one is rolling dice second time simultaneously, and we have to find the probability of happening event. These types of probability can be solved by using multiplication probability theorem. In other words, multiplication probability theorem is used to find probability of events occurring in first task. Intersection concept is used to find probability of all occurring events. Intersection concept is also a key concept of mathematical probability and set theory. Similar as union concept, it is noted as intersection. Since two events can occur simultaneously in different two tasks, if an event depends on the event of different trials, it is dependent event, otherwise it will be independent event. So mathematical formulation for independent dependent will be slightly different. It is known as multiplication probability formulation for dependent events and multiplication probability formulation for independent event respectively. So multiplication probability formulation for dependent event is slightly different from independent events happening in more than two tasks. Multiplication probability formulation for dependent event is generalization of the multiplication probability formulation for independent events. So let's start with the multiplication probability formulation for dependent event. Multiplication probability formulation for dependent events, for that we suppose two events that are dependent occurring in two different tasks. So E and F are two dependent events, that is outcome of one is affecting the outcome of second events. One more thing is that second event will happen after completing first task, so that conditional probability concept is used in multiplication rule. So multiplication probability formulation for two dependent events is given as probability of E intersection F is equal to probability of E given F into probability of F. the mathematical formulation is given here as, the formulation can be read as probability of even E and F is equal to probability of even E given F, even F that has given even probability of even E given F where event F has already occurred into probability of event F. So multiplication probability formulation for three dependent event E, F and G is given by probability of E intersection F intersection G, which is equal to probability of E into probability of F given E, probability of G given E intersection F. This formulation can be read as probability of event E, F and G is equal to probability of event E, probability of event F given event E into probability of event G given event F and G. Similarly, multiplication probability formulation can be extended to n dependent events. Two cards are selected from a deck of cards followed by one without replacement of the first card. What is the probability that first card is club and second card is ace? So now we will discuss how to solve this type of problem. Suppose E is an event of selecting first card as a club, F is an event of selecting second card as an ace. E and F events occur in two different trials. Second card is selected after first card in second trial with no placement of first card in the deck of cards. So E and F affecting each other and are dependent events. Multiplication probability formulation for dependent event is used to find out the probability that second card is club ace. The probabilities are given here as probability of F is equal to 13 by 52, probability of E is equal to 4 by 51 and probability of E given F is equal to 1 by 51. Multiplication probability formulation for two dependent event is probability of E intersection F is equal to probability of E given F into probability of F, and probability of E intersection F is equal to 13 by 52 into 1 by 51. So after solving this, the final answer is coming out to be 0.0049. That means probability of first card club and second card club is 0.0049. Now we will discuss probability formulation formula for the independent events. Suppose E and F are two independent events of two different tasks, that is happening of one event is not affecting the happening of another event. So the multiplication rule formula does not contain conditional probability. It contains simple multiplication of events. Multiplication probability formulation to calculate probability of two independent events is given as probability of E intersection F is equal to probability of E into probability of F. This formulation can be read as probability of event E and F which is equal to probability of event E into probability of event F. So multiplication probability formula for three independent events E, F and G is given as probability of E intersection F intersection G, which is equal to probability of E into probability of F into probability of G. Similarly, multiplication probability formulation can be extended to n events as needed. Now let us discuss another case. Suppose a person has BMW, Ferrari and Fortuner luxury cars. He also has Puma and Action shoes. If he wants to choose one luxury car and one shoes at random, what is the probability that person choose Fortuner luxury car and Puma shoes? Suppose E is an event of selecting Fortuner luxury car and F is an event of selecting Puma shoes. E and F are independent events. Because selection of one does not affect other, multiplication probability formulation for independent event is used to find out the probability of E and F events. Probability of these events are given as probability of E is equal to 1 by 3 and probability of F is equal to half. Multiplication probability formulation for two independent events given as probability of E intersection F which is equal to probability of E into probability of F, and probability of E intersection F which is equal to 1 by 3 into 1 by 2, and after solving we will get the answer as 0.1666. So probability of choosing Fortune and Puma shoes is 0.1666. Now it's time to summarize this module. In this module we first discuss the basic terminology that is required to understand the concept in depth. After that we discuss different concept, that is additional theorem, multiplication rule, and we discussed this concept with under the cases of mutually exclusive events, non-mutually exclusive events. We also discussed conditional probability concept here, and we use different examples to understand the concept in very easy manner. And in this module, we also discuss that how one can understand the problem and use these concepts and apply these concepts to solve these types of problem. Hope you can understand the concept in depth. Thank you.